Question 10 is our integration by substitution questions, and it says to use that x is equal to sine theta. So if x is equal to sine theta, we're going to try and change this dx into something to do with d theta. So let's differentiate. Dx by d theta is cos theta, and so dx is cos theta d theta. But why is that useful? Well, we've got 1 minus x squared here. X is sine, so we can write that as 1 minus sine squared theta to the 3 over 2 times by cos theta d theta. We also have these limits to do with x, but we've now got thetas in our question, so it's going to be worth changing the x's into thetas at some point. We may as well do it now. So because x is equal to sine theta, let's look at when x equals a half. We've got a half equal to sine theta. And when does sine theta equal half in radians? Well, let's inverse sine a half, and we get pi over 6. So that's my new theta upper limit. And the other one's easier, it's just x equals 0. And when does sine theta equal 0? Well, that's when theta equals 0. So my lower limit is just 0. So what have we got going on here? Well, we've got a 1 minus sine squared theta. That is cos squared theta. So we've got 1 over cos squared theta. In fact, let's not write it as 1 over. Let's write it as cos theta over. Let's bring this cos theta above the fraction. Cos theta over cos squared theta to the 3 over 2. Well, cos squared theta to the 3 over 2, that squared is going to cancel with that square root. So we've got cos theta over cos cubed theta d theta between pi over 6 and 0. Cos theta over cos cubed theta is 1 over cos squared theta. But, can't integrate that, but what is that equal to? That's sec squared theta. And we can integrate a sec squared theta. Integrate sec squared theta, hopefully you know what you get tan theta. So putting our limits in, tan of pi over 6 is root 3 over 3. Tan of 0 is 0. So our final answer is root 3 over 3.